Okay, let's start. So good evening guys. So we were discussing about a system of particles and rotational motion, right? So in last class we were discussing about the question, find the center of mass of the three particles at the vertices of the equilateral triangle. The masses of the particles are 100 gram, 150 gram and 200 gram respectively, and we have got the points. No, these points are, if we know the points, we can find the x center of mass and y center of mass. Is it plane or is it one dimension?
One dimension. A plane.
It's a plane, no, two dimension, no. So I need to find both of them, right? Yes, no. Okay. So next we will go for the topic. Find the center of mass of the triangular lamina. Okay, triangular lamina. Okay, we need to find for this. So here the answer is here. A lamina may be subdivided into narrow strips, each parallel to the masses, which is mn. Okay, so by symmetry, each strip has its center of mass at its midpoint. Yes, no. When I talk about a rod having a center of mass in the midpoint, no. So when I take a strip, each strip is a parallel thing. So for each strip, the center of mass will be at the center, right? No. If we join the midpoint of all the strips, we get a median called LP. Okay, this is the median. So the center of mass of the triangle as a whole, therefore, has to lie on the same median, right? No. So when I talk about this one strip, this is my center. Second strip, this is my center. Third strip, this is my center. If I join everything, I will get a median. So every center lies in this same median, right? Yes. So similarly, we can argue that it lies on the median, that is MQ as well as RN. Okay. So we will do a problem on this. Yeah. Find the center of mass of a uniform L-shaped lamina with dimension as shown in the given figure. The mass of the lamina is 3 kg. Okay. So mass of the lamina they have given. So can I divide this lamina into 3 parts?
So we'll get 3 centers.
So 3 center of masses. For this one center of mass, this one center of mass, and for this one center of mass we will get, right? So if I divide into 3 equal parts, so this is 1 kg, 1 kg and 1 kg, right? So this is my given thing, right? No. So this is 0, 0, this is 2, 0. What about this one? 1, 0, right? And this one is 1, 1 they have mentioned, and this is 1, 2. Now we know that for a lamina, no, everything lies in the center, no. So what will be this center point for this one and this one? Let me consider this is my A, B and C. Okay, for A, what will be the point? Okay, but the point I should know, no? Yes sir, no, the point I should know. So can I say that this is 0 and this is 1, divide by 2 means 1 by 2 I will get. So x is 1 by 2. What about y? This is 1. So again 1 by 2. Can I say the point as 1 by 2, 1 by 2? Yes, no. So for this, center will be like 1 by 2, 1 by 2. What about the object C? 1 plus 1 by 2, which is nothing but 3 by 2, no? 3 by 2 is in x, but 1 by 2 in y. So can I write like this? 3 by 2, 1 by 2. And for this one?
3 by 2,
1 by 2, 3 by 2. Yes. So 1 by 2, 3 by 2. These are my points we know, right? No? Now we know the mass also. So can I write? Yes. Which one? This one. This one. 1 plus 1 by 2, 3 by 2, y. This is 1 by 2, x. So x, y. Right? So now x center of mass will be equals to m1 x1 plus m2 x2 plus m3 x3. Okay, divide by m1 plus m2 plus m3, right? Now So what is m1? So this is 1, 2, 3.
M1 equal
I can take commonly outside. I can
m by 3.
cancel it.
So
Right? No. So
x1 plus x2 plus
mass are same. No. So what I can do? 1 plus x2 plus x3 by 3m. 3m. No.
3 m and m.
I have taken m commonly outside. 1 plus 1 plus 1. 3 m and m I cancelled out. So x1 1 by 2, 3 by 2, 1 by 2. So 1 by 2 plus 3 by 2 plus 1 by 2 divide by 3.
3
Right? No. So 1, 4, 5.
by 2
5 by 2
by 3.
by 3. Right now? So what will be the answer? 5 by 6 is the answer. So this is for x center of mass. So what about y center of mass? Can you give answer for this?
Same 5 by 6.
Same 5 by 6. Because 1 by 2, 1 by 2, 3 by 2. Here 3 by 2, 1 by 2 and 1 by 2. Right now? Same. You can take a note of this.
So x center of mass, y center of
Done. So we will get y center of mass also same, no? So y center of mass will be equals to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. So we will get m commonly outside. We can take m commonly outside. This is 1 by 2 plus 1 by 2 plus 3 by 2 by
3.
m into 3. So m and m can get cancelled out. So what it is? So 5 by 2 by 3, which is nothing but 5 by 6. Right? Completed? Can we go for the next one? Yes. So motion of a center of mass. Okay. So motion in the sense, what are the things we can tell? Velocity, acceleration. Right now? So first thing we'll talk about the position. Yesterday we have talked about the position, no? Center of mass of the position. So when we talk about the center of mass of each particle, mass 1 into position 1 plus mass 2 into position 2 by mass 1 plus mass 2 for two particles. Summation mi ri by summation mi. Right? No. So down part, can I say the total mass? Yes, no, the total mass. So if I take the total mass into the other side, mr is equals to m1 r1 plus m2 r2 plus up to mn rn. Right? No. So similarly, if I take this one and if I differentiate with respect to time in both the side, what happens? M dr by dt is equals to m1 d r1 by dt plus d r2 by dt plus up to drn by dt. Right? No. So what is r by t? Velocity, right? So dr by dt, I got mass into velocity, which is nothing equals to m1 v1 plus m2 v2 plus up to mn vn. Okay, this is for velocity. When we talk about acceleration, what we can do? Again, I can differentiate with respect to time. Dv by dt, which is nothing but acceleration. So here v1, I mean dv1 by dt, dv2 by dt up to dvn by dt. So velocity by time is acceleration, no? So same thing. Here we will get mass into acceleration will be equals to m1 a1 plus m2 a2 plus up to mn an. Okay. So this is not 2, this is n. Okay. Take a note of this. Done. Done. Completed. Now, so we have talked about the velocity and acceleration, no? So now the force. So we know that if we talk about this thing, no, we know that mass into acceleration known as force, right? No, so F will be equals to F1 plus F2 plus up to Fn, the same thing. So F1 is equals to m1 a1. So for F1 is the force of the first particle. What about F2? Force of the second particle. Fn is force of the nth particle, right? No, so if I add everything, what I will get? The sum of force of the every particle, which is nothing but a sum of, I mean force of the rigid body, right? Now take it. Done. Finished, Kunal? Done. Okay. Okay. So this was the thing we were discussing about. Okay. So next one, a linear momentum of a system of a particle. Okay. So two things we have learned. One is acceleration, one is velocity. So for the acceleration, we know that mass into acceleration known as force. Similarly, mass into velocity, can I tell us momentum? No. So we have got the relation, that is mv is equals to m1 v1 plus m2 v2 up to mn vn, right? No, so mass into velocity is nothing but momentum, which is nothing but p1 plus p2 plus up to pn. So the linear momentum of the system is nothing but p is equals to p1 plus p2 up to pn. So it, which can be expanded as m1 v1 plus m2 v2 plus up to mn vn, right? So the total momentum of a system of a particle is equal to the product of the total mass of the system and the velocity of the center of mass. Okay. Done? Completed. So next topic is conservation of linear momentum. So if an external force acting on a particle of acting on a system is 0, which means the external force will be 0, right now. So here if external force is 0, momentum by time will be also equals to 0, right now, which we have seen in the Newton's law, no? Yes, no, Newton's second law. The force is equals to momentum by time, right now. So if it is 0 means momentum will be constant, right now. So consider a heavy nucleus radium moving with velocity u, okay, and it split into a nucleus radon and an alpha particle. So here F external is 0, which means momentum is conserved. So center of mass of the system continues to stay in the same straight line. Yes, no. If there is no external force, it will go in the same straight line, no. So center of mass continues to move with the same velocity. Done? Completed? Okay. So now we will see the vector product of two vectors. So in motion in a plane we have talked about vectors and scalars, no? The same thing. So a vector product of a two vector A and B is a vector C. Product of two vectors, no, will be equals to a vector C. Okay. So here how can I tell us this is my first vector, this is my second vector. I am going from first vector to the second vector. The resultant vector will be in the which direction I need to find. So first vector I am going to the second vector, resultant vector will be upward. Okay. Suppose this is my first vector B, second vector is A, which means second vector to the first vector, resultant will be towards down. Okay. X2 Y means resultant will be Z, Y2 X means resultant will be minus Z, right now. So A cross B will be equals to AB sin theta. So where AB sin theta is the magnitude and n cap is the unit vector which is perpendicular to the both A and B. Okay. So that's the thing, right and screw rule we have used. Okay. So here from A to B I am going, resultant will be outside, B to A means resultant will be inside. Okay. If you use left hand it won't come. Okay. So vector product of two vectors, that's the thing. So A cross B will be given as AB sin theta, or B cross A will be minus no.
360 minus
The thing is simple. A to B I am going, it's outside. B to A means inside. So opposite side, no.
Then 180 degrees it should be.
It will be total. So 360 minus theta, so minus n cap will come. Okay, no? So A cross B will be equals to minus B cross A. Okay. So the vector product is not commutative. So but scalar is commutative. AB will be equals to BA. Okay.
A dot B.
Yeah, A dot B will be equals to B dot A, whereas A cross B will not be equals to B cross A. Okay. Yeah. So vector product is distributive. So A cross of B plus C will be equals to A cross B plus A cross C. If two vectors having a same magnitude and same direction, which means
Theta is
A cross A will be equals to A square, which is angle will be between them is 0 degree. No, sine 0 is 0. So which means A cross A will be 0. Okay. So for unit vectors, I cross I will be equals to 0, I cross J will be equals to 0, K cross J cross J will be equals to 0, K cross K will be equals to 0. So I, J, J and K, K. Okay. But when we talk about I cross J, J cross K, K cross I,
1.
it will be simple thing. I, J, K.
I cross J is
So I cross J will be equals to K. Okay. From I to J, if we will get K, J to K. So J cross I will, K will be equals to I. So K cross I will be equals to J. Okay. So this side if we go, it is positive. If we come in this side, it is negative. Okay. So negative in the sense, how we can say? So K cross J minus I, no. K to J I am going, result will be I. Then J cross I will be minus K. I cross K will be minus J. Okay. Because the angle between them will be 90 degree, sin 90 is 1. Take a note of this. Done? Yeah. See here. So A cross B will be equals to AB sin 90. So which will be sin 90 is 1. Okay. So here we have seen here I cross J will be equals to K, J cross K will be equals to I, K cross I will be equals to J. Yes, no? So J cross I will be equals to minus K, K cross J will be equals to minus I cross K will be equals to minus J. Simple thing, I, J, K are the three things. Okay. So if two things are given, the third will be unknown, but only the direction we should remember. Okay. Yeah. So here the thing is given, A is equals to AX I cap, plus ay j cap plus az k cap. B is equals to bx I cap plus by j cap plus bz k cap. Okay, so when I do the cross product of them, okay, so simple thing, we know that I will be 0 right now. I need to multiply now, I cross j, I cross k, again j cross I, j cross j, j cross k. For this also k cross I, k cross j, k cross k, right na. So for this we will use a method, a that method. Okay, so I, j, k, ax, ay, az, bx, by, bz. Okay, I will teach you here. So now some 5 I cap plus 6 j cap plus 7 k cap is the value of A. Okay, A vector. So B vector is given as I cap plus j cap plus k cap. Now I need to find A cross B, which is nothing but 5 I cap plus 6 j cap plus 7 k cap cross I cap plus j cap plus k cap. Right now, simple thing what I can do here, first plus minus plus I cap, j cap, k cap. Okay, so what are the values here given? First thing 5, 6, 7, 1, 2, sorry 1, 1, 1, no, let me take 1, 1, 1 only. Okay, so equals to, what is the first sign? Plus. Keep plus as it is. This is for I cap.
6 minus.
This one minus j cap, again plus k cap. Okay, so when I want to do for I cap, no, close I, cross multiply
6 plus 7.
6
Minus 7.
minus 7, 6 minus 7. Okay, when I want to do for j, close j and this one. Okay, row and column I should close it, row I should close, column also I should close, which means 5 minus 7. For k I should close row and column. Okay, so 5 minus 6, so 5 minus 6, so plus of minus I cap, minus of minus 2 j cap, this one plus of minus k cap, which means minus I cap plus 2 j cap minus k cap. This is my answer for the given vector. Okay, note it down. Completed? Okay. So here is the problem. Find the scalar and a vector product of two vectors. First thing what they are asking, a scalar product, which means A dot B, right? No, A dot B. Second one is a vector product, A cross B. Can you give answer for the both the cases? The thing is, I dot I will be
1.
I dot I will be 1, J dot J will be 1, K dot k will be 1, whereas I dot j will be 0, j dot k will be 0, k dot I will be 0. Okay, so you can use this cases and get the answer for the scalar and vector.
Sir, and there is a minus, right?
So 3i cap minus 4j cap plus 5k cap minus 2i cap plus j cap minus 3k cap.
Take symbols in the
Yes.
matrix.
Yes, including symbols also we should take in the matrix.
First one answer minus 6i minus 4j minus 15k.
First one is minus 2. It's a scalar product, na? So scalar product means a dot b, which is equals to 3i cap minus 4j cap plus 5k cap dot minus 2i cap plus j cap minus 3k cap. So I can get the answer, but I dot j will be 0, I dot k also will be 0, j dot I also will be 0, j dot j I can get, j dot k also 0, right na? So can I say 3 into 2 is, sorry, 3 into minus 2 is minus 6, minus 4 into 1 is minus 4, 5 into minus 3 is minus 15. So 15, 19, 25 minus 25. Right?
Yes, correct.
Correct na? So can we do for the vector product or cross product? So A cross B will be equals to, take the matrix, I cap, j cap, k cap. What is what is value of A? 3, minus 4, 5, B is minus 2, 1, minus 3. Right now, can I erase this one? Yeah. So now A cross B will be equals to first plus I minus j plus k. So when I want to find I, close I row and I column. So minus 3 into minus 4 into minus 3 is 12 minus 1 into 5 is 5. Okay. Now when I want to do for j, close the j column and j row. So 3 into minus 3 is minus 9, minus 2 into 5 minus 10. So minus of minus 10, which is plus 10. So when I want to do for k, close k column and k row. So 3 into 1 is 3, minus 2 into minus 4 is 8. So here minus 8 we will write. Okay, no? So 12 minus 5 is 7i, minus 9 plus 10 is 1. So here minus is there, minus j cap. Here 3 minus 8 is minus 5. So here plus, so minus 5k cap. So this is my answer for the vector product. Which one, sir?
4 minus 2 into minus 4.
Where? So 3, which one we are doing?
Okay.
For k. So 3 into 1 is 3, minus 2 into minus 4 is 8, but 3 minus 8 we should write, no?
Oh.
Yes, no?
Nice.
So if they are asking the magnitude of the vector, no, what we will do? Modulus, which means root over 7 square plus minus 1 square plus minus 5 square.
Sir, what's the point in keeping negative?
I have taken the sign as it is. Okay, no. If we don't take the sign also, no issues. Right now, same answer we will get. So 49 plus 1 plus 25 under root 75. Ah. Done? Completed? Okay. So next is angular velocity and its relation with a linear velocity. Okay. So we have talked about a linear velocity, no? So what is linear velocity? A displacement by time. Similarly, angular velocity also we have talked about, right now. So what is angular velocity formula? D theta by dt. Angular displacement by time. Right now? So we know that V is equals to ds by dt. So omega is nothing but angular velocity, no? Which is equals to d theta by dt.
d theta equals to ds by dr.
Yes. So consider a body which is rotating about x-axis. We have taken here that for the diagram. So every particle of a body moves in the circular path, right now. So linear velocity v of a particle is along the tangent. Along the tangent. So let's p dash be the position of the particle after an interval of time delta t. So the angular displacement is delta theta. So the average angular velocity will be delta t theta by delta t. So instantaneous angular velocity is d theta by dt. Okay. So angular velocity is a vector quantity. Okay. So angular velocity and its relation with the linear velocity we need to find now. So we know that s is equals to r into delta theta. Okay. So if we differentiate with respect to dt in both side, okay. So ds by dt is equals to r into d theta by dt. Here this is the displacement, I mean this is the traveled path, no? S will be equals to r into d theta, I mean delta theta, no? That's the thing we have taken. So if we differentiate with respect to dt on both sides, so this is my velocity. This is my angular velocity. So the relation between the linear velocity and angular velocity is nothing but r omega. Okay, r omega. So in vector form v is equals to omega cross r. So we have got the relation for the angular velocity and linear velocity. So similarly, can we get the relation for the angular acceleration and linear acceleration, which is nothing but same equation I will take, differentiate with respect to time. dv by dt is equals to r into d omega by dt, which is nothing but dv by dt is equals to r into d omega by dt. So it is acceleration which is equals to r into alpha. Alpha is nothing but angular acceleration, right now. So for uniform rotational motion, both magnitude and direction of omega remains the same. Direction of v changes continuously. Take a note of this. Yeah. Done? None. Okay. So angular acceleration, the time rate of change of angular velocity. So d omega by dt. So angular acceleration, which is denoted by the symbol alpha. Done? Okay. So with this we'll complete the session. Okay. We'll start with the upcoming session with the next topic. Okay. You can wind up.